Okay, this is lesson 2 for binomial distributions, and we're going to look at probabilities dealing with binomial distributions. And we'll talk about the difference between a binomial probability distribution function and a binomial cumulative distribution function. In the calculator, it's the difference between PDF and CDF. Okay, when you're doing probabilities with binomial distributions, where you find this information is a little bit different. For one thing, you're not going to go to stat anymore. You're actually going to go and you're going to hit the second button on the calculator, and then you're going to go and you're going to hit the VARS button, V-A-R-S. And what that does, it takes you to a list of distributions. Alright, in this list, you're going to scroll down, and it's really toward the bottom of the list, and you're going to look for binomial PDF or binomial CDF. Okay, the difference between the two, like I said, probability, this is a probability distribution function and this is a cumulative distribution function. Okay, now the difference here is that it's worded in the question, so really we need to look at a question to kind of distinguish the difference here. So let's look at this question. Okay, it says, the brand name of McDonald's has a 95% recognition rate. If a McDonald's executive wants to verify that the rate verify that rate by beginning with a small sample of 15, I know what we need here. 15, recognition rate is 95%. Let's see what we need. Find the probability that exactly 13 of the 15 consumers recognize the McDonald's brand name. Also, this is a different question, so we'll get to that one in a minute. Now, your keyword with binomial, another keyword to help you if you don't check, first of all, you should always check the 4 qualities for binomial, but you can also look at the word exactly. That's a good indication that you're going to do a binomial distribution. Okay, so I want exactly 13 of the 15. Well, exactly also tells you you're going to do a PDF, because you're looking for a certain number, not a range of numbers. So in this case, what you need once you do this, I'm going to go to binomial PDF in the calculator, and what they're going to ask you for, or what you need to do this, is you need the sample size, because you're going to put in the parentheses your sample size, the probability of success, and then the number that you're selecting. Okay, so if we're looking at this particular example, what we want to do is we're going to take binomial PDF. We're looking at 15. Our probability of success is 95%. That's our probability of recognizing the brand name McDonald's. And then I want to know exactly 13. Okay, once you type this in, you are going to get 0.135. A lot of people say, well, that sounds really small. If I have a 95% recognition rate, why is that number so small? Because you're only looking at the probability that 13, that exactly 13 of those 15 are going to recognize that. If you look at exactly 12, exactly 11, exactly 10, all the numbers and add them all up, it can't exceed 1. So each individual one has to be somewhat of a smaller number. Okay. Now let's answer the second question. The second question says, also find the probability that the number who recognize the brand name is not 13. Well, not 13, that's just the complement rule. Well, if we know this is how many for 13, this is exactly 13. So if I want to find not 13, then I just do 1 minus 0.135. And the reason why we're going to do that is because it's just the complement. So it's 0.865. So if I want to know probably that the brand name is, or who recognized the brand name is not 13, it's 0.865. That doesn't tell you how many there are. It could be that exactly 12 or 11 or 10 or 9, but that's the sum of all the rest that are not 13. So that's the sum of 0 through 12 and then 14 and 15. And that's why that number's higher. Now, another type of distribution that we do with binomial is a cumulative distribution. Okay, the difference here, again, let's look at a different question. All right, it says, in the United States, 40% of the population have brown eyes. Okay? If 14 people are randomly selected, find the probability that at least 12 of them have brown eyes. Now here's the difference. This key phrase of at least 12. That symbolizes a range of values. Well, what does at least mean? Well, at least 12 means 12 or 13, up into how many people you're choosing, or 14. That's what at least 12 means. It means 12, 13, or 14 are going to be or have brown eyes in this case. What numbers are not included from this sample set? Well, anywhere from 11 to 0. Now, because the calculator always does less than, if you're trying to do anything with more than, like at least or more than or exceeds or greater than, then you have to do 1 minus in the calculator every single time. If it said less than, you'd be good to go. So I'm going to do 1 minus binomial CDF. Okay. Total sample size 14. Probability of success, in this case having brown eyes, is 0.4. And how many I want to have. Now this is a little tricky. Since 12, 13, and 14 are in the greater than category, I want this to go up into that point. So I'm going to stop this at 11. Because if I go to 12, then 12 is in my less than, and I don't want that. So it's kind of, you have to figure out what number to put here, and that makes it a little bit confusing. If this said greater than 12, okay, then you would have 13 and 14 here, and this would be 12, because 12 is not included in your upper. It's kind of like you have an upper number and then a lower group of numbers. So you have to figure out that dividing line, and that just takes some practice. Okay, when you do this, and don't forget where to find them. You're going to go to distributions to do this. You're going to get 0.30. Be careful with scientific notation. Okay, so it's going to be 0.000609. And again, we did 1 minus in the calculator. If you forget that 1 minus, it's going to be wrong. Alright, so you're going to get 0.00609. So the question states, is it unusual to randomly select 14 people and find that at least 12 of them have brown eyes? Well, yes, this is definitely considered unusual if you go back and look in your notes, because what constitutes unusual is a probability less than 0.05. Since this is obviously less than 0.05, it is considered unusual that in a group of 14 that you're going to have at least 12 who have brown eyes. All right, so that's the difference between binomial PDF and binomial CDF.